Hello and welcome, everyone, to another interesting session in our Basic Electrical and Electronics series. Today's topic is very important. We'll be comparing AC versus DC transmission. Let's begin. In this video, you will learn what is transmission, the basic concepts of AC and DC current, what is HVDC transmission, features, advantages, and disadvantages of DC and AC transmission, and finally, a comparison between both systems. Let's start with the basics. Transmission is the process of carrying electricity from power plants to the distribution systems that supply homes and industries. It happens at very high voltages like 66 kV, 132 kV to 20 kV, or even higher. Why high voltage? To reduce energy loss when electricity travels long distances. Transmission happens after generation and before distribution, and it can be done using either AC or DC, depending on the need. Let's recall the basics. AC, alternating current. Here, the current changes direction periodically. In India, this happens 50 times per second, 50 Hz. DC, direct current. In this case, the current flows in only one direction. Both AC and DC can be used for transmission, but they have different characteristics and are used in different scenarios. Now let's look at HVDC, or high voltage direct current transmission. HVDC is mainly used for very long distances, especially when we need to reduce power losses. It's also used for special cases like underwater cables, where AC would lose too much power, and for interconnecting regional grids, where synchronization is tricky. Now, what exactly is DC transmission? It is the transmission of electrical power using direct current, where the current flows in one direction only. Key features include, it uses just two conductors, one positive, one negative. There's no inductance or capacitance involved. Voltage remains constant, with no variation over time. Let's look at the pros and cons. Advantages: lower transmission losses, ideal for long-distance and underwater cables, no interference with nearby communication lines, narrower conductors can be used because of lower loss. Disadvantages: voltage cannot be easily stepped up or down, no simple transformer use, DC switchgear and breakers are more expensive and complex, not ideal for short distance or local distribution. Now coming to AC transmission, it uses alternating current, which reverses direction at regular intervals. In India, this happens 50 times per second, or 50 Hz. Key features: it uses a three-phase system with 3 or 4 conductors. Voltage and current follow a sinusoidal wave. Transformers can easily step up or down the voltage, making it very flexible. Now let's look at its pros and cons. Advantages: easy and cheap voltage conversion with transformers. Equipment like switches, breakers, and lines are more affordable and widely available. AC is the standard for domestic and industrial power supply. Disadvantages: higher transmission losses due to inductance and capacitance. Skin effect, where current flows more on the outer surface of the wire. More conductor material may be required than DC. Let's now compare AC and DC transmission based on key technical and practical factors. 1. Current direction. In AC transmission, the current alternates direction, typically 50 times per second in India. In DC transmission, the current flows in only one direction. It's steady and unidirectional. To equipment cost, AC systems use transformers, which are cheaper and widely available. This makes AC transmission cost-effective. On the other hand, DC systems need expensive converters and special switchgear, so the overall setup cost is higher. 3. Voltage control. In AC transmission, voltage can be easily stepped up or down using transformers. This is very useful for transmission and distribution. In DC transmission, voltage control is more difficult since transformers can't be used directly with DC. 4. Transmission losses. AC systems suffer from more losses due to inductance, capacitance, and skin effect. DC systems have lower losses, making them better for long-distance transmission. 5. Suitable for AC transmission is suitable for short to medium distances, like urban and rural power distribution. DC transmission is best for long-distance and underwater cables, where AC losses would be too high. 6. Interference. AC transmission can interfere with nearby communication lines due to electromagnetic fields. DC transmission has no such interference, making it ideal for power corridors near telecom lines. 7. Usage. AC transmission is the standard for domestic and industrial supply systems worldwide. DC transmission is mainly used for HVDC lines, grid interconnections, and special cases like underwater links. Both AC and DC transmission have their own benefits. The choice depends on the distance, cost, and efficiency needed. And that wraps up today's topic on AC and DC transmission. We covered their definitions, features, advantages, and where each one is used. If you found this video helpful, please do like, share, and subscribe for more clear and simple videos on electrical engineering. Thanks for watching, and I'll see you in the next class.